I would like you to get your notes out, please. And we are on page 64. And the whole point of today is we need to see why we actually care about this stuff. There are some interesting things we can do. Like, we've just kind of done like math stuff with lines. But there's some interesting ways that lines can be applied to some real world problems. And that's what we're going to see over here. So we are on page 64. Little bit before lunch, more after lunch. So again, we need our notes out, please. And yes, there will be probably a word problem on the test like what we're about to go through here.
I went to the Marshfield Fair.
You did?
Yep.
Were tickets $3.50? No? Well, this year, they were $3.50.
I did go to.
You did. Who else has been to the Marshfield Fair?
No.
I have not. This could also be a name that Mrs. Reap just made up. I don't know. I think I'm going to believe Shane on this one. So, here's what the problem says. The rides at the Marshfield Fair, at the Marshfield Fair have an additional cost of $3.50 beyond the admission fee of $10. So what this means is everyone who goes to the fair pays $10 no matter what. But then if you want to go on a ride, you pay an extra $3.50. And if you want to go on 2 rides, you pay $3.50 twice for the 2 rides. That's how they figure out how much they're going to charge you. This year that they did it, they did. And we see a table showing how much you're going to pay based on how many rides you went on. You go on 1 ride, you pay $13.50. You go on 2 rides, you pay $17. 3 rides, $20.50. 4 rides, $24. Letter A. If this pattern continues, what is the total cost for 5 rides and the total cost of 10 rides? How can we figure out what 5 rides are going to cost? There are a couple ways, and by the way, can you take a moment right now and get your calculators out, because we're going to need a calculator for this stuff today. Especially because these are messy numbers with the decimals in there.
Can I get my phone?
You may not get your phone. You may get your calculator out of your bag.
If I told you I didn't have a calculator.
Then I'm going to tell you you're on your own.
Well, it's a good thing I have one.
It is a good thing you have one. I know, you're very funny. Okay, so let me ask you this. To go from 1 ride to 2 rides, we added how much money? Because I told you it was $3.50 for every extra ride, right? So to go from 2 rides to 3 rides, we added how much? $3.50. We added $3.50. So how much would 5 rides be? What do you have to do? How did you get that? You added $3.50. So how much would 5 rides cost? $27.50. Can you just add another $3.50 then to get your 10 rides?
No, because it's double the amount.
Ew. It's actually a little bit different than that. So first of all, you can't just add $3.50. Brian, what do you want to say? Yeah, so that's kind of what Darius was saying. The issue is because they charge you $10 no matter what. If you just multiply this by 2, it would be like they charge you the $10 twice and then the 5 rides twice. So I like part of the multiplying by 5, but other parts, do you see what I'm talking about? It's going to multiply the $10 fee you paid no matter what. That's why we're going to have to do this a little bit differently. What we could do for 10, you know what we could do for 10 rides? How about I just make a new chart? 6 rides, 7 rides, 8 rides, 9 rides, 10 rides. How about you fill in how much those are going to cost? We know that 5 rides is $27.50. How about you figure out 6 rides? Okay, what is $27.50 plus 3? $3.50 rather. 30. Not 30. $31?
Oh, yeah.
$27.50 plus $3.50, $31. Take your calculator, figure out 7, 8, 9, then we'll have 10, and we'll see it's not quite going to be what double 5 rides was. Okay, we're making that little chart, right? We're filling some things in, figuring out 10 rides, how much that's going to cost you. Let's go, 7 rides. What's 7? $34.50. 8 rides. $38. 9 rides. $41.50, good. And 10 rides? How much is 10 rides going to cost? $45. That is not $27.50 times 2, again, because of the $10 you had to pay no matter what. Now, go down to letter D. How much will 27 rides cost? Do you want to do this?
No.
Why do you not?
It's too expensive.
It's going to be a pain to do this by continuing the chart. What we're going to see after lunch is if we can make an equation of a line that models this situation, we can just plug a number into a formula and it will tell us right away, you're going to pay this rather than having to make this really annoying chart 27 times. And what if it was 153 rides? You really don't want to continue that. After lunch, we're going to see how to turn this into the equation of a line and then do some stuff with that. So I'm going to stop this here. So before lunch, we talked about how to figure out how much 5 rides would cost, how much 10 rides would cost. You didn't want to do 27 because you said it would be a pain to continue the chart and all that stuff. And I mentioned that we can use lines and formulas to be able to do this very, very quickly. What I would like to do now is I would like to make a graph of this data that we have here, and we're going to do that on the next page in our notes. Turn the page, please, to page 25. Yeah, and we're only going to do this for the first problem. After this, we're going to learn a shortcut for being able to write a formula for the situation very, very quickly. Page 65, the next page. 1 ride. How much does 1 ride cost? Guys, you got to get here when the bell rings. Look back. What did it say? Well, $3.50, but that's beyond the $10 you paid in the beginning. So that is $13.50. I'm going to put a little dot at 13. Oh, this is not a good grid. Well, whatever. I'm going to put a little dot at $13.50. I'm going to say it's about there. Headphones up, please. And phone on the side, please. $13.50. 2 rides were how much? Look at your chart. 17. So I'm going to put a dot at 17, which is halfway between 16 and 18. Now, I want to get a couple more, and then I'm going to do that. 3. 20.50? Okay, so 3 rides is a little over 20, maybe about there. I'll do 1 more, and then I think that'll be good enough. 4 rides? 24 even. Oh, that's a good one. I would like you to use your ruler and connect the dots. And my goal is now to write the equation of this line. And it's going to be a little weird. That's what part B is going to ask us for, but I think I'm going to do it right over here. The equation of my line, of course, is y equals mx plus b. Do you see what your b is? What does b stand for? Y-intercept. Do you see where the line crosses the y-axis? Here's the y-axis. Where does it cross the y-axis? Nope. 10. Do you see that right over here at 10? Is where it's hitting it? My b is 10. The slope is weird. As you go from this point to this point, your rise, your run, well, so we're kind of like in between spaces here. But I think to go from 13.50 to 17, aren't we rising $3.50?
Yeah.
And aren't I going over like one space as you go from 1 to 2? I need to kind of include the scale on the axes when I figure this out. My slope is $3.50 over 1, or just $3.50. My equation is y equals 350x plus 10. And this is going to be the key to making predictions about a whole lot of rides that I don't want to continue in my table. Turn back to page 64. Part C, write the equation of the line. We already said it was y equals 3.50x plus 10. But there's more to it than that. The x and the y. Flip back to 65 and tell me how the x-axis was labeled. There was a word on the x-axis, Kaylin. Number of rides, x, that variable is going to stand for, in this problem, the number of rides. Kaylin, could you also, since you're at it, tell me what the y stands for? The cost. And I now have a formula that I can use to make some predictions about how much certain things will cost. Letter D. I want to determine the cost of 27 rides, and I do not want to continue my table. 27 rides. Is that 27 rides an x value, or is it a y value? What was that? Y? X? I think if we flipped back to here, like Kaylin said, the x-axis was labeled as the number of rides. The y-axis was labeled the cost. Therefore, when I tell you 27 rides, it's like I'm telling you an x value. We should be making some notes about this. This is not easy stuff. I told you an x value. What this means is I can plug that in where the x is, and my answer, the y, would be the cost of 27 rides. I'm going to say y equals 3.50. What did we say our x value was? What number? 27, the number of rides, plus 10. We now need our calculators out. Order of operations says what first, the addition or the multiplication? Do it. 3.50 times 27. Okay? 3.50 times 27, what is that? 94.5 or 0.50 because it's money, plus 10. Yes. Your final answer. This is how much it's going to cost if you go on 27 rides. That would be a lot of money. $104. The year we wrote the problem, it wasn't a pass. It was you pay for each ride. But $104. But isn't this a nicer way to do it than continuing the chart?
Yes.
And that's kind of the point of this. One more. Letter E. How many rides could you go on if you have $80? Well, if I'm telling you you have $80, is that an X value or is that a Y value? It's Y because Y is the cost, and I gave you the cost here. That $80 is a Y value, which means I'm going to make the little equation 80 equals 3.50 X plus 10. Hold on one moment. Make sure you write that equation down. Darius, what do you want to say? You mean like it's an equation we have to solve? Absolutely. How do we solve something like this? Well, we're going to go do minus 10, minus 10, I think that'll give us 70 equals 3.50x. Do what? Divide by 3.50, absolutely. You're definitely going to want your calculator for that. What is it?
I knew it.
How many rides could you go on?
20.
20 rides.
Because 350 is half of 7. And if you just add a 0.
Oh, because of the 10, yeah, that would make some sense. So, the idea here is if we have some information, we can make the equation of a line. Once we have that, to answer all sorts of prediction questions, we just have to plug in numbers and either plug in and you're done, or plug in and solve an equation. Now, I want to go back to that equation that we wrote because it was a little bit of a pain to have to graph all those points, especially because they weren't nice numbers. My equation, y equals 3.50x plus 10. Do you see a 3.50 in the problem somewhere? Go back to the original paragraph of the problem.
Yeah.
Where do you see 3.50?
The number of
The cost of what? Of what? Of one ride. Do you see a 10 in the problem somewhere? Where?
additional cost.
The how much you pay no matter what. All of these word problems are going to work out the similar way. Our answer is y equals mx plus b. The m is going to be the cost of each ride, of each hour, of each day, of each whatever the situation is. And the b is the cost you pay no matter what. You always pay the $10 to get into the fair. And then this is the extra you pay for every ride. Turn to page 66. If we're given a word problem and we're asked to write the equation, our equation is y equals mx plus b. The b is what we call our fixed cost, the amount you pay no matter what. The fixed cost. The m is what we're going to say is our cost per day, or per ride, or per whatever the problem is dealing with. The cost per day, ride, etc. And the fancy name for this is the variable cost. The cost that is different based on how long you're doing something, how many rides you're going on, something like that. And with these ideas, we don't have to make a little graph first. We can go straight from the word problem to an equation and then use it to make our predictions about later on. So I'm going to wait till people are done getting that in there. And then we're going to take a look at one more example together before I give you a few to try on your own. Okay. In our example, we're told that a canoe rental service, cross off the S, charges a $20 transportation fee and then $30 an hour to rent a canoe. Everyone's paying $20. Then you pay an extra $30 for every hour that you want to be on the canoe. I want to write an equation in my line. Y equals. What is the M going to be? The 20 or the 30? Let's go with Shane.
Transportation fee.
So the 20?
Or no, $30.
30? Darius? Pedro? Caitlin? Yeah, it's the one that changes based on how many hours you do something, so we're going to make it the 30. 30x. What's the B? 20. The amount you pay no matter what. Everyone pays $20, then you pay $30 per hour. Now, as far as what the variables mean, in these problems, the y will always end up being how much you end up paying in the end. I'm going to label that my cost. And the x, I guess in this problem, because they're talking about hours you're doing that, x will be the number of hours. So we're going to do two prediction problems. Let's get that mask up, please. If you're doing this for 6 hours, is 6 x or is it y? X, 6?
It's the amount of hours.
Yeah, and y is always the cost. We don't have the cost, we have the hours. So what we're going to go do is we're going to plug in 6 where the x is. We're going to go do the problem, y equals 30 times 6 plus 20. You go do it, and when you're done, make sure you stick a $sign on your answer. So let's finish this one off. Now let's stick a $sign on there. And here I want to see an equation, and I want to see some algebra. But not with some algebra. So I'm not ready for that. This one. This one, you're plugging in 6 for the x. Good. No. This isn't an equation. This is just order of operations. All good, and now just finish it off and do that addition problem. Because it's not like an equation where I'm going to get the variable's already by itself. Give me the number and then do $sign. Yeah. Yes, good. I know you read it with it afterwards. Okay. So I would first write down what we said the variables were. X is the number of hours, y is the cost. I gave you in this problem the hours, so we're going to fill that in where the x is. And we're going to make that equation. Now go do that math problem. Go do 30 times 6, and then add 20. Good? And because it's money, put a little $1 back and forth. $1 on just like that. Got it. Good. Okay, so order of operations says 180 plus 20, that's going to give us $200. Perfect. Next, letter C. How long can you rent a canoe if you have $140? Is $140 the X or the Y? Y, because it's the cost. So here's where we need to do a little bit of algebra to solve this, and I am going to want to see how you're using this equation to solve that. I'm going to remind me again, 140 for X or for Y? Y. We're going to say 140 equals 30X plus 20. And then I need to see how that gets solved. Do it, and when you're done, add a little, oh, sorry, you can't see that. Solve that, and when you're done, add a little word to the answer because it's a word problem. Tell me 72 hours or something. It's not 72, but give me the hours at the end. Let's go do it. I think it's actually a nice round number answer. Yeah, but again, I'm going to be looking for some algebra, not homework. I feel like we lost a variable. Don't lose the X. Good. Good. Not $4 though? 4? How long can you rent it for? You can rent it for $4? No. Yes. Yes. Marcos. Yeah, equals 30x. So right now equals 30x. That's it. Okay. Exactly. Go sign out and hold on. Marcos, I'll be right back. But you didn't. You didn't. Maybe you did. Oh, now it's showing up. It just showed up. Okay, go. Yep, so it's going to be 4. How long? 4 hours. How long? Not yet. Not $4. How long can you rent it for? You would say 4 hours. You say 4 hours. You're going to be on. So, we're going to solve this thing. We're going to do minus 20, minus 20. We're going to get 120 equals 30x. Divide, divide. 4 equals x. So how long do you have that canoe? You have that canoe for 4 hours. Do you see how this is working? Okay, I'm going to turn this off.